All right, I think I'm live now. Okay, I'm sorry that it took a little bit a minute for me to figure that one out. I accidentally made an unlisted video. Yeah, I spent like 5 minutes being like, where is everybody? I told everyone on Discord just to come onto YouTube, and no one came. Looks like it worked out. Okay, here we go. Okay, yes, we have a couple people now. Okay, yeah, I was a little confused there for a second because I had 0 viewers for like a few minutes, and I know it usually takes a couple minutes for people to stroll in, but I was a little surprised. I was like, 0 people, come on, where is everyone? I was feeling lonely, I was all by myself, and then I realized, oh yeah, I made this video unlisted. Because I've been experimenting all afternoon with, you know, adjusting the video quality 0 people, and everything, because now where is everyone? I was feeling lonely. Nothing seems to work. So I and then I realized, oh yeah, I made this video unlisted as I do that, and then I just realized, oh yeah, unlisted. No one can. Because I've been I was a little surprised. So yeah, as I was saying, in like all by myself. With, you know, adjusting the video quality
hello,
0
Jello.
Where is everyone? I was feeling lonely. I was just saying I got a new microphone. I hope that it myself. And then I realized, oh yeah, I made this video unlisted as I did. I just realized, oh yeah, I was streaming at home, because I've been, I was a little surprised. So yeah, as I was saying, in like all by myself, with, you know, adjusting the video quality 0 Jello. Where is everyone? I was feeling lonely. I was just saying I got a new mic. Oh, that okay? Yeah, I had my desktop audio on. I'm hoping that fixed it. Thank you for pointing that out. I really appreciate it when you tell me when something is wrong, because I hope that you kind of understand what I'm saying when I say that, like, I'm spending all day trying to make this go smoothly, and I feel, and if I'm cutting out or anything, please let me know. Like, basically right now, my computer is frozen. Nothing. I can't click on anything. My computer's completely maxed out. Okay, and every like 10 seconds or so, everything moves, and the reason for that is because it's a really old CPU, and there's no video card, so everything is being done on the CPU. So my CPU is just completely maxed out. Yeah, my CPU is at 100%. I'll show you what I mean right now. All of the resources are going. See, this is my CPU right now. 100%. It's just going like full tilt, trying to catch up with everything. And even then, I've reduced the settings. We're now at 720p instead of 1080p, 30 frames per second instead of 60 frames per second. So the old CPU is struggling, but I guess it's doing technically what it is supposed to. It's just not doing it very well. So we're gonna just have to deal with it for today. But yeah, if anything is going wrong that makes the video unwatchable, or like if it's giving you a headache, please let me know, and we will we'll address that. So anyways, let's start doing some math. Like, I know that I've just been blabbering nonstop about streaming and that kind of thing, but it's on my mind, and I think you can imagine why. Okay, so yesterday I started talking about, for the very first time, I started talking about systems of equations. So systems of equations, oopsies, wrong tool. The marker is what I want. Okay, so systems of equations is where you have many equations with several variables, and you're trying to solve for more than one variable at a time. And the ones that we are going to look at, and I know that I already wrote this yesterday, but I want to just add to this a little bit. In this case, we will have 2 equations, and we will look for with 2 variables. Okay, so that's really what we're doing. So the idea here is that when you have the 2 variables x and y, right, we can graph the relationship between those. So really what we're going to be doing is we're going to be looking at 2 functions. and we are going to look at where those functions intersect. And that's what we mean when we solve a system of equations. So let's try another example. And again, it's just going to be a visual example. So what I want to look at today is, so given one linear equation, and one quadratic equation, how many solutions can we have? Okay, that's what we're going to be looking at. Is my voice still doubling? Please let me know if my voice is still doubled up. I thought I fixed it. I'll try just putting everything else on mute except for my microphone. Yeah, let me know if my microphone is still muted. You could also let me know on Discord, because that actually goes to my phone, whereas my computer is just like, it's totally bogged down right now. Like I don't even know if I'm still live right now. So yeah. Anyway, yeah. So we're gonna look at one linear equation and one quadratic equation, and we're gonna see how many different solutions could we have. Like, we're not gonna look at how to get those solutions yet. What I want to look at is just what are the possibilities for the number of solutions. So when I say solutions, what I really am talking about is points of intersection among the two graphs. That's really what we're looking for here. So let's take a look at kind of the most typical example. So if I had something that looked like this, right? I've got my x and y axis. So here's my y axis, here's my x axis. Okay, if I were to graph one linear equation, let's say something that looks like this. There we go. Here is our linear equation. And if I were to graph another quadratic equation, something that looks like this, a nice little parabola. So here's my quadratic. Okay. Well, you can see here that there are 2 points of intersection. Okay. 2 points of intersection. Okay. I'm just going to quickly send a message to the Discord folks just to see if, like, I'm live, if I'm able to be seen, because I'm not seeing anything on YouTube, and I just don't know if my computer's frozen or if I've actually gone offline. Sorry about this. My mic is a little bit quiet. Okay, I'll try to bring it in a little bit closer. Yeah, it's not the best microphone in the world. I'll try to just speak up. I'll try to maybe just raise my voice a little bit, and hopefully that will make me a little more audible. Yeah, so like I said, please just let me know if there's anything about the video that is distracting or anything like that, and I'll do my best to try to fix it. I may also just have to go back home and just start streaming from home again, because this is getting a little ridiculous. Anyway, I'm hoping that that's better. Okay, so I've got 2 points of intersection in this particular example. So let's see if there's a way that we could have 1 point of intersection. I wonder if that's possible. So again, what I'm going to do is I'm going to draw my my set of coordinates. So I've got my y-axis, I've got my x-axis. Here's my y-axis, here's my x-axis. And So I'll start off with my linear equation. Actually, you know what? First, what I'm going to do is I'm going to start off with my quadratic equation. So here's my quadratic equation. There we go. So here's my quadratic. Okay. And if I were to make a linear equation that intersects this quadratic at just one point, it would look something like this. So what I'll do is I'll choose the point where they intersect first. Let's say maybe this point right here. So maybe that's our point of intersection. And then if my linear equation passed it just once, well, it wouldn't be able to look something like this, right? Even though it looks like this would only pass it once, well, if it kept on going, it would actually cross it 2 times. So remember, I'm looking for a line that passes this exactly once. So that's my goal here. So let's see how that would work. So if this was to pass only once, well, basically, it would have to just graze it, right? So it looks something like this. So kind of like it's getting closer and closer. Oh, and then it touches it, and then now it's getting further away. So it's actually just touching it in one single point like this, okay? And this would be my linear equation. This would be the point of intersection, point of intersection, okay? And what we call this, we have a special name for this case. What we would say is that the linear equation is tangent to the quadratic. And this happens when they intersect at just one point, okay? So what I mean by tangent is that you could kind of imagine that this was a roller coaster, right? That the quadratic equation was a roller coaster, right? And on a normal day, the roller coaster, when you ride it, it just goes down, and then whoa, everyone cheers and is, feeling a little bit sick. Maybe they puke their popcorn or whatever. So they're just on the roller coaster. On a normal day, that's what happens. On this terrible, tragic day, there is a catastrophic failure right at the point of tangency, right? That's what we would call the point where the tangent line touches the quadratic. And what happens on this catastrophic failure is that, the track on our roller coaster breaks right at this point. That's what we call the point of tangency. So it's not a normal day, it's a tragic day. And we're going down on the roller coaster just like normal until we hit that point of tangency. And then whatever kind of direction we're going at that point, that is the direction that we go. So this would be the direction of the roller coaster. Now, keep in mind, there's going to be gravity. So in real life, it would actually be more like this. Like we would start off doing that line of tangency, and then we would all, it would be very sad. But the idea here is that this point of tangency right here, like these two lines look pretty much identical. So the closer and closer you get from, like if you just kept on zooming in, these two lines, as you get closer and closer to this point of tangency, they would actually be the same. So they would look almost identical. Of course, this one has some curvature in it. This one is straight. But as you zoom in, the curve starts to look a little more straight. And right at this point where they touch, they're actually going in the same direction. So that's the only way it's possible for a quadratic equation and a linear equation to intersect at just one point. So if there's one solution to this system of equations where one of the equations is quadratic and the other equation is linear, then we know that one of these is tangent to the other. The linear equation must be tangent to the quadratic equation. So like the slope of this line, the slope of this linear equation is going to have the slope that the quadratic equation has right at this point here. And I know that it's kind of weird to think about slope on a quadratic. That's not really something that we study. But we can imagine what the slope would be right at this point, right? So you could kind of think of choosing any one of these points, and then the tangent line would kind of follow the slope at that point. So that's kind of what I'm talking about. So you choose a point, and then that would be the point of tangency, like that. It's only crossing it at one single point. If we chose the vertex, for example, well, the slope at the vertex is going to be 0. It's going to be a flat line. So that's another option. So yeah, that's definitely one option. So just reviewing what we're talking about. So here we have 2 points of intersection. So that means that we would have 2 solutions to this system of equations. Here we have 1 intersection. So we would have 1 solution. And I wonder if maybe you can see what's going to happen next. The other possibility is, well, here is my coordinates. And the other possibility is, well, I've got maybe a linear equation that looks something like this. So here's my linear one. And my quadratic one, which I'll do in pink, doesn't intersect it at all. That's totally possible. So here's my quadratic. And between these two, there are no intersections. Okay, so I've got no intersections in that case. So this corresponds to 2 solutions, right? 2 points of intersection. That's equivalent to saying that there's 2 solutions. Here we would have 1 solution. And finally, we would have no solutions. Now, you might be saying, hey, this is similar to looking for the roots of a quadratic, right? Like looking at the x-intercepts, remember? So I'm just going to write note, just like there can be 2, 1, or 0 x-intercepts in a quadratic, I should say quadratic equation, there can be 2, 1, or 0 solutions to a system of equations with a system of equations with 1 quadratic and 1 linear equation. Okay, so that's kind of the moral of the story today, is that there's 3 possibilities for the number of solutions. Okay, you could have 2 solutions, you could have 1 solution, or you could have no solutions. So what I'd like to do is I'd like to head over to Desmos and just kind of explore some of the possibilities that we could have for our system of equations. So unfortunately, I don't have a keyboard here that I can use. I wonder if maybe I can, here's Desmos. Okay, so I'm in Desmos now. I'm going to just throw myself into the second line. You know, I'm going to steal the keyboard off my computer here, so just give me 2 seconds. And I think this one, please don't break anything. I think this is the keyboard. Must be, because the Windows key doesn't work anymore. Okay, please work. Uh-oh. Come on. Okay, so that was not my keyboard. Give me 2 seconds, yeah? Let me just try to find my keyboard. I don't know what this thing is then. Oh, this must be it. I have a feeling that this is like my worst stream ever. But what are you going to do, right? Okay, I'm pretty sure this is my keyboard. Aha! Yay, it's working. Okay, so let's start off with the equation. Let's just do a simple one. Let's do y equals 2x minus 1. Okay, just a nice little simple equation. So here it is. It's got a y-intercept of 0, -1. It's got an x-intercept of 0.50, yada, yada, yada. I'm hoping that we're comfortable with these types of equations already, right? Nice, simple, linear equation. Not a whole lot going on. Yeah, my computer is like completely frozen. I can move the mouse, but the mouse clicks don't do anything. So it'll be interesting to see what it's going to look like to end this stream, because I don't know how to end it if I can't click on anything. Like I hit the start button, and now the start button is just like, it's locked. Anyway, by the way, I can't see your YouTube comments or your Discord comments anymore because my computer's just, like I said, it's frozen. So I'm hoping that you guys are still here and that everything is working out okay. Anyway, so here is my my linear equation. Let's throw a quadratic equation and see what we can do. I'm going to put the quadratic equation in vertex form. So I'm going to say that it's going to be 1/2, that's going to be my stretch factor, x minus 2 squared, okay, plus 1. Okay, so this one here I'm going to zoom out. Okay, that looks pretty good. So I've got 2 points of intersection here and here, and you can see right off the hop that like these are not nice numbers, right? So the example that we did the other day, we kind of estimated it, and we got like I estimated like 1.25 or something. So what I want to just kind of give you a hint on what we're doing is what we're trying to do is we're trying to say, okay, there could be 2, 1, or 0 solutions to these systems. Now, that's the first place to start. The next thing you're going to want to be able to do is figure out what these numbers actually are. And I'm hoping that you can recognize that these are going to be some kind of square root of something. Just like when we found the x-intercepts of a quadratic equation, we're pretty much doing the same thing here. Is we're looking for solutions to both of these equations. So that's where we're headed. That's what we're going to try to do tomorrow, is look at how we can use algebra to solve these things. And it turns out that the algebra isn't too bad. It's really not the hardest stuff in the world. But it is going to take a little while for us to fully develop an understanding of this. So yeah, that's what we're doing. And later on, what we'll try to do is we're going to try to have situations where we actually have 2 quadratics. Okay, so if I have 2 quadratics, that's going to look something like this. So maybe I'll have, maybe let's do negative. Oops, that's not what I wanted to do. Negative 2/3 times x plus 1 plus 7. Oh, and that's supposed to be squared. X plus 1 squared. Okay, so you can see here, now I have 2 solutions, right? I've got 2 solutions here. So we would be looking at different ways of finding those ones. So that's kind of what we're doing here. I'm hoping that over the past couple of days I've been able to describe what our plan is and where we're going with this. So, I mean, some of the reasons why you would want to do this kind of thing is you can have an equation represent all sorts of things, right? And sometimes you're going to have 2 equations, right? Sometimes you'll actually have 2 equations that represent different things, but the variables are the same. Kind of like maybe you could look at like the amount of money that you would make by selling a particular product, right? And at the same time, you'd be looking at the cost of making that product, right? So you'd have 2 equations sharing some of the variables together, like cost and profits and things like that. And sometimes you want to see where those 2 things intersect. And that's kind of the point of this, is that sometimes one equation is not enough, and what you really need is two equations, or even more than two equations. It's very common, and that's something that it's a huge topic in university, something called linear algebra. And in linear algebra, you look at ways of solving huge systems, like systems with like 5 or 6 or 7 or many equations with just as many variables. And it turns out if you have, like, let's say 7 variables, let's say you've got 7 variables, then the only way you can solve that is if you have at least 7 equations. And that's true for n in general. So if you have n variables, then you'll need at least n equations to solve that system. And that's really fun stuff. It gets really interesting. So I'm going to end it there. I'm going to try to end it. I mean, I can't even close the start button, so I have no idea how I am going to close this stream. So if anything, I might just, like, I don't think I can even turn the computer off. Yeah, I mean, are you guys still here? I mean, like, I'll show you what I'm dealing with here. I'll go back to my note-taking program. Like, so I can't, like, this doesn't, it's not doing anything. This is just completely frozen. This is OBS over here. This seems to be working okay. Here's another tab. Like, everything is just not responding. Like, this is the task manager. I can't seem to do anything. Like, I'm completely frozen up. So I wonder if, I really have no idea what to do. Okay, oh, here it stopped again. I wonder, I mean, that was the last frame that it was able to load at the very beginning of the class, where I had 0 viewers, and yeah, okay. So if you want, you can go now. The class is over. I'm just going to spend some time trying to end this. You can hang out if you want, but yeah, I'm done. I'm just going to spend a few minutes trying to end this stream. What a nightmare this is. Oh my gosh. Yeah, I might just see if I can start streaming at home. So take care, guys. I miss you. I wish we could just have a regular class face to face, but obviously we can't. Okay. I might just shut the computer down. I mean, it's kind of a extreme, like, okay, maybe I'll plug the computer back, or the keyboard back in, and do the old, oh, I'm back. Oh, okay, I think it didn't like the fact that I unplugged the keyboard. Okay, I clicked end stream. Come on, you can do it. End it. Oh, I wonder if I can just go into OBS. Okay, oh yeah, I'll go into OBS. OBS seems to be responding. Let me hit stop stream there. Okay, so I think this is actually goodbye. Goodbye, everybody. If you're still watching, thank you.